Hi, this is Lawrence Orijuela. You're probably familiar with my older brother, Giovanni Orijuela, who's the instructor for CSE5250 parallel programming. Well, he kindly asked me if I could make an assignment for your class, so I went ahead and did that. So, my understanding is that you're learning MPI in his class. So I remember when my older brother and I took 6250, which is the graduate version of 5250, and we learned the exact same thing, the exact same structures, the exact same code in Professor Gomez's class when he was still teaching that. So at this point, I'm going to assume that you're already, well, maybe not really good, but you know the basics of MPI programming. I'm going to pull up a little something here. So, the core thing that you need to know about MPI is the send and receive processes. So MPI stands for Message Passing Interface, and there's the two main things you need to know is how a process can send to another process and how a process can receive from another process. So the send function requires 1, 2, 3, 4, 5, 6 arguments. One is the data tag. This data type here, it could be an int, a double, or string, but the most important thing is that it has to be of type pointer so that the data can change when it receives it. Int count is how many items are in the data that's going to be received. So in many cases, if you're receiving just an int or a double, count would be equal to 1. But if you're sending a vector of ints or a vector of doubles, then count has to be equal to whatever the size of the vector is. MPI data type. There's actually a lot of different MPI data types. So if you were sending an int or a vector of ints, you would have to set this to MPI underscore int, all uppercase, or MPI underscore double, all uppercase. The next argument is the destination. So if a process is sending something, who's going to receive it? The destination has to be equal to the process number which this process is trying to send data to. Last is the tag. We don't really use the tag that much, so you can always set this to 0. And then last is the MPI communicator. This one is always the same argument each time. It's MPI com world. Okay? Now, as for the receive function, there's 7 arguments. We have a data type here, which is also going to be of type pointer, because it has to be. Int count. What is the size of the message that we're receiving? If it's just one item, just set count to 1. But if it's a vector of items, you have to set this equal to the size of the vector that you're sending. Next is the MPI data type. I already explained that. Source. Source is just like the inverse of receive. So who do you have this receive function, right? Which process is going to be the one sending you what you need, right? Int tag, you can always set this to 0. MPI com, this is going to be the same thing each time. It's going to be MPI com world. And then lastly, we have something called the status. So receive functions require a variable called status. You have to make a status variable of type MPI status. And what the purpose of the status is that it will be a value of 1 if it receives correctly, or 0 if it doesn't. So I'm assuming that you already know the basics of sending and receiving. So assuming that you do, we will go down to the lab. So this is a very simple program. This is probably the simplest program I can think of that can use parallel programming. So what you're going to do is make a program that creates a square times table. So if the size of the square is 7, you need to display times tables of up to 7. So 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 8, 12, 10, 12, 14, you know, that kind of thing. So in this exercise, you will program. This is the way that we're going to do this using parallel programming. Now, you can probably code this without parallel programming, but what would be the point of this class, right? So this is the method by which you're going to write the program with MPI. So you will create a program that runs on n processes to create an n-1 times n-1 times table that will behave in the following way. Process 0 will receive one vector of size n-1 from each of the other n-1 processes and output their contents, starting with process 0 and ending with process n. So if n equals 7, then process 0 will be receiving from 6 different processes. If n equals 10, process 0 will be receiving from 9 different processes. Make sense? So what's going on with the other n-1 processes? Well, each one of these will send one vector of size n-1 to process 0. And that vector will contain the first n-1 multiples of its own process number. Okay? So I have a little diagram here. This is a sample of what's going to happen if the process number in this, if n equals 4. So imagine there's 4 processes, right? So process 0, it's doing what it's supposed to do. It's going to have this code here. So int rank equals 0. So as always, rank is equal to the number process that you are. So since process 0 is process 0, its rank is going to be equal to 0. And then we have com size here. So since there's 4 processes, the com size is going to be equal to 4. Now, this information is shared between all processes, so I didn't bother to copy these 2 lines of code into here, here, or here. But now let's see what process 0 is doing. So for int I equals 1, that's right, you're going to start the index for this for loop at 1 because we wouldn't start from 0 because process 0 is already taken up. Okay. So starting from I equals 1, going to com size, I plus plus, process 0 is going to receive a vector from process, and then the index is I, so we're going to say I. And then we're going to check to see if the receive was successful, okay? So we're going to have another for loop here. I index this one j, because I was already taken. So for int j equals 1, j is less than the size of the vector that we received, j++, see out the contents of vec at j. This is supposed to say j, but I see it says I, so I'm going to have to fix that later. But yeah, that's what it's supposed to do. And process 0 is reliant on receiving each and every one of the sends from each of the other processes. So let's take a look at what each of the other processes are doing. So processes 1, 2, and 3, they're doing the same thing. So send a vector of 1, 2, 3 to process 0. The reason why is because process 1 has a rank of 1. So we will send 1, 2, 3 to process 0. Process 2 has a rank of 2. So we will send a vector of 2, 4, 6 to process 0. Process 3 has a rank of 3. Send 3, 6, 9 to process 0. Imagine what would happen if this said 4. So process 0 would still be the same, but over here on the left, instead of 3 boxes here, there would be 4 boxes called process 1, process 2, process 3, process 4. And each of these would have 4 arrows pointing to the output here. And instead of comp size equals 4, it would be comp size equals 5. So this is a sample of if there were 4 processes. So you can probably use this to visualize what it would look like if n was some different number. So I said here, watch video for assistance. This is the video in which you're going to refer off of. Okay. So very short assignment. It's only 1 page, but now it's time to get down to business and start coding this thing. So here's what you need to do. Open Visual Studio. I like using 2019. Recently they came out with 2022, but I'll just use 19 because it's reliable. So you're going to choose C++ empty project. You're going to save this somewhere. I'm going to save this over here. And we will call this MPI times table. Okay. Go ahead and click create. It decided to open here for some reason. Okay, so go ahead and right-click source files, click add new item. Choose this, and I guess we'll name this times table.cpp. Click add. Okay, so we're gonna. I think I can make this bigger. Let's see. There we go. So we're going to code this the same way we would like any other C++ project. So we're going to include IOStream using namespace standard. Int main. Now for MPI programs that's going to be running on command line, you're going to have to put some other stuff inside of the int main. You need to say int argc, comma char star argv, like that. Okay. We're going to say return 0, like that. However, because this is an MPI project, we're going to need to include a couple other things too. So the first thing we're going to do is include mpi.h, like this. Right now it's an error because we need to add this still. Don't worry about it. We'll add it later. But we need a couple other things too. So we're going to need all these. So this is just some stuff that you need for every MPI program. So you're going to need int IR to track your errors. You need an int to track your rank, and then com size to track the com size. Okay. And then as something that you're also going to need before return 0 is that you're going to need to say IR equals MPI finalize. This is all just code that you need for MPI projects, okay? And then this needs to be said before your return 0 always. Okay, so now that we have this, we can go ahead and start adding the MPI libraries. Now, hopefully my brother already gave you the instructions already. So this is what you need to do. Go to project, go to properties, click this C/C++ thing here on the left. Click additional include directories, click this arrow, click edit, click this button, click this triple dots. Now you're going to need to go to C, Program Files x86, Microsoft SDKs. You're going to need to go to MPI. And then you're going to select this include folder here. So select this folder. Click OK. Okay, so what this does is that includes the additional directories. Now, the next thing we're going to need to do is include the library directory. So to do that, you get a linker here. Right next to additional library directories, you're going to have to click this arrow, click Edit, click this, and this time we're going to go to C drive, Program Files x86. We're going to need Microsoft SDKs. We're going to go to MPI. We're going to choose lib, and here we're going to choose x86. Select, click OK. Okay, great. That's great. Lastly, we need to include additional dependencies. So right underneath linker, click underneath this arrow, click input. So at additional dependencies, click this arrow, click edit. And in this box here, you're going to type in msmpi.lib. Click OK. Click apply. Click OK. Right. So as you can see, this error went away. So now that means we have MPI installed. Okay, perfect. So now that we have this going, we can start coding our lab here. So this is basically the way we want to do it. Now, so depending on what number you put in the command line, there's going to be n different processes, each running the exact same code. However, if you want each process to differentiate in what they're doing, you indicate that by referencing their rank number. So, for instance, if I want process 0 to do something, then I would say if rank equals 0, and I would say I want process 0 to do this. And then you could say if rank equals 1, and you can say I want process 1 to do this. Like that, see? But process 0 is going to be, for this particular program design, process 0 is going to be doing a specific thing, but processes 1 through n is going to be doing the exact same thing, but just slightly different. So here's what we're going to do. Let's think about what we want to happen if rank does not equal 0. So for this here, this code is only going to execute for processes that aren't process 0. Okay. So maybe that's a good comment to put. This code will only execute for processes that aren't process 0. And then we can put an else here, and then we can put another comment here. This code will only execute for process 0. So when you're coding these MPI labs, one thing that you need to understand is that depending on the number of processes you choose, all of the processes are using the exact same code. But like I said before, the way that you differentiate what each one is doing is referencing them by their rank number. Okay? So what do we want this process to do if it's not process 0? Well, that's really easy. We need to send a vector of size n-1 to process 0 containing the first n-1 multiples of its own process number. So that's really easy. So I guess over here we're going to include vector. Like that. And over here, we need to send this. We have to make a vector of n-1 and send it to process 0. So here's what we're going to do. We're going to say vector int. Name this vector anything you want. I'm just going to call it sending vec because it's a vec that we're sending. And then we can say for int I equals 0, I is less than com size I plus plus. So, oh, excuse me, this shouldn't be 0, it should be 1, because we don't want to include 0 here. So by making it start at 1, we're making it so that we're excluding zeros in the timetable. Okay. So we're going to reference our vector. We're going to say sending vec, and then we're going to push back it's rank number times I. So rank times I. Just like that. Okay, perfect. So let's think about what happens if com size was 4, just like in this example, and we were looking at process 1, whose rank would be 1. So if we were talking about a com size which is 4 and rank which is 1, then we would put the following numbers into this vector. So 1 times 1 is 1, 1 times 2 is 2, 1 times 2 is 3. We've reached com size, so the vector would only contain the values 1, 2, 3. What if we were looking at process 2? So if this was process 2, its rank would be equal to 2. So we would push back 1 times 2 is 2, 1 times 2 is 2 times 2 is 4, 3 times 2 is 6. So the vector we would send is 2, 4, 6, and so on. I think you get the picture, right? Okay, so now that we've constructed the vector, we now have to send it to process 0. So if I open this documentation again, you'll see that all sends have to have 1, 2, 3, 4, 5, 6 arguments. So we're gonna say MPI send. Now we need to reference the data in which we're trying to send. So we're gonna say sending back. However, this needs to be an address, so we're going to put the address of operator in front of this. And another thing that you're going to need, because this is a vector, because this is a container of multiple objects, you're going to need square bracket 0 in there. I never understood why, but it's just something that you need. Now, if you were just sending an item that's of 1, that contains 1 object, like just normal int or normal double, you actually wouldn't need this. But you always need to have the address of operator, because this is of type pointer. Okay. So the next variables you need is count. So what you would need to do for the next argument is put the size of the vector here. Now, the size of the vector, because of the way we coded it, its size would always be com size minus 1, right? So I guess we could, right before this line, we could say int size equals com size minus 1. And we can put size as the next argument. Next, we need the MPI data type. So because this is an int, we're going to need to say MPI underscore int that. Okay. Next, we're going to need its destination. Now, we're always only... So for this program, we're always only sending messages to process 0. So put 0 in there. That way it'll get sent to process 0. The next one is the tag. As I said, you can always have it be 0. Next is the communicator. So for this one, you're just going to put MPI com world. Just like that. Okay. 1, 2, 3, 4, 5, 6. Okay, perfect. So every process that isn't process 0 is going to be sending something to process 0. So in order to make this work, I'm sure that Giovanni has already gone over this with you already, but every send has to have a receive. Every receive has to have a send. If there's a send without a receive or a receive without a send, you're going to have deadlock. Okay. So, we need to create a receive process for every send we have. Well, how many receive processes is that? It's going to be com size minus 1 receives, right? So the best way I can think of doing this is by having a for loop that iterates through 1 to com size, and then having a receive function inside of it. So here's what I'd like you to do. Say for int I equals 1. We're starting from 1. We wouldn't start from 0 because we want this to iterate com size minus 1 times, right? So we're going to say I less than com size I plus plus, and then we're going to have a bunch of stuff in here. So when we receive the vector, we're looking at process 0 right now. Process 0 is going to ignore this code and just execute this code, right? So here's the way it's going to work. We need a place to store the thing that we're receiving. Okay, so maybe just make a new vector, int, and we called the last vector sending vec. So I guess we'll call this one receiving vec because that's what it is. It's a vector that we're receiving. That. And then we're also going to need, what else do we need? Okay, so I just remembered that receive needs a 7th argument called status. So here's how you're going to do that one. We're going to say, you're going to declare a variable of type MPI status. So MPI underscore status, like that. And give it a name. I guess we'll just call it status. Just because why not? And then the size of this vector needs to be the same size as the vector that's being sent to us, right? So here's what we're going to do. We need to call vector's resize function. So let's do this. We're going to say int size is equal to, it's always going to be com size minus 1, right? That. And I guess down here we'll change the size of receiving vec. So receiving vec dot resize, and it needs a variable here. Here we'll input size. Okay. So here is the part where we make use of the IAir function, or it's not a function, it's a variable. So we need to check and see if our receives are successful. If they are successful, we'll proceed. If they're not successful, we'll abort the process, because we don't want to like mess up our computer or anything. So we're going to say IAir is equal to MPI underscore receive. So in case you didn't know, this function MPI receive, it returns a 1 if it's successful and a 0 if it wasn't successful. So that's the reason why I'm setting IAir equal to MPI receive. Okay. So we're gonna need to put a bunch of arguments here. We're gonna put the data that we want to fill in. So in this case, we're going to fill in our receiving vec. We're gonna put the address of operator since it needs to be a pointer. Back like that. Since it's a vector, we need this 0 in square parentheses. We need to say the size of it. So I already made a variable for size, so we'll put size in here. The data type is going to be MPI underscore int, like that. We need to indicate what we want to receive from. So because we're receiving from 1, 2, 3 all the way to n, and we already have this for loop iterating from 1, 2, 3 all the way to n, we can just put I as our source. Okay. The tag can simply be 0. We're gonna put MPI com world, and we're gonna put our status variable here. Now, if you look back in here in this website, status needs to be a pointer. So I'm gonna put status here, but put the address of operator in front of it. Okay. So now that we have that, we're gonna say if IAir equals MPI success, this assumes that the receive was successful, else. But if the receive wasn't successful, then we'll just abort the process. And the way you do that is with MPI abort. And then you pass MPI com world to it, comma 1. But assuming it was successful, if it received the vector from process I, you simply want to output its contents. So let's do this. So for int j, I have to use j because I was already taken. So int j is equal to 1. J is less than the size. So in this case, the size is always going to be equal to com size minus 1. So since I already created a variable for that, I can just put size here. And we can say j plus plus, like that. Now, here's actually what I want it to do. Because I care about the formatting of how I want to do this, let's use the IOMinit library and use the setW function. So if I set the width to 4 maybe, I can have my output set like this. I can have 3 spaces, then the number 1, then 3 spaces, then the number 2, 3 spaces, then number 3. It's called set width 4 because each of these is a width of 4. So this makes it so that if my multiples were like a high number, like say 10, it would be 2 spaces, 10, 2 spaces, 20, 2 spaces, 30. This also has a width of 4. So I'm going to scroll back to the top, include IOMinit, like that. And back down here, I'm going to say cout, and I'm going to use the set width function that the IOMinit library gives me. So set width 4, like that. And we will output receiving vec at index j, just like that. And after each time we output the contents of the vector, we're going to end the line. So we're going to see out end line like that. And let's see. Is that everything? So I'm going to scroll down slightly. That could be everything, I think. So this will handle everything that's not process 0, and this will handle process 0. Lastly, we have to say MPI finalize right before I return 0. So I believe that should be it. You can use this video to add more comments explaining what each part of this code is doing. But I think if that's it, it's time to run it. So the thing about MPI programs is that you actually can't run this in the debugger. It requires a command line argument because of this. So here's what you actually have to do. You have to use your file explorer, navigate to the place where your thing is located. Okay. Now before you can actually do that, on Visual Studio you have to press Control B to build without actually running it. Okay. So once succeeded. Alright, so go back to your file explorer, go to the location of where it is, go to your debug folder, and here it is. This is our executable. This is what we want to run. So in your file explorer, click this here, type cmd to open a command line that's at this exact address. So the command to actually do this thing is MPI exec -n, and then we say the number of processes we want to run. So since we want to try for 4 first, let's put 4. And then we can say the name of our executable, which is MPI times table.exe, and you know it's that because it's the same name as this thing here. Okay, so let's run this and see what happens. We should see 1, 2, 3, 2, 4, 6, 3, 6, 9. That's weird. What did we do wrong? I think what we did wrong was oh, pardon me. This needs to start from 0. Sorry about that. So let's Control B again, and then give this another try. So MPI exec -n, say 4, MPI times table.exe. There we go. So This is running exactly how we want to run it if there are 4 processes. But we can vary the number of processes we want. The way that we coded it, the process should be the same. Process 0 just receives however many number of vectors from all the other processes. So instead of saying 4 processes, we could say 10, and we get this. So the way that I want you to visualize this is that these are the outputs given by process 0. Process 0 is telling the items of the vector received from process 1, then the items of the vector received from process 2, then from 3, 4, 5, 6, 7, 8, 9. If I really wanted to, I could go up to 15. If I said 15, process 0 would be receiving 14 vectors from 14 different processes, resulting in a 14 by 14 times table, like this. Okay. So, Giovanni, I hope this is a good enough assignment for your class. So yeah, really grateful that I get to contribute to the class that he's teaching. But yeah. So me and Giovanni, we're actually brothers. We both teach at CSE5250. So yeah, funny how life works that way. So anyways, I hope you enjoyed this video. I hope you learned something from it. I hope you get a good grade too. So yeah, that's it. I'll see you guys.